Okay, so this video, I'm going to continue to go over the section 4.4, the non-homogeneous second order differential equation, and we solve it using the method of undetermined coefficient. So what we are doing is to derive the method of undetermined coefficient. So the last time, let me see, we figured out that for a given differential equation, a y dou prime plus by prime plus cy is equal to c times t to the mth power. So if the source function, or I can say external force term, so the source function has the form, the monomial like this, then the solution, I told you y sub p doesn't mean particular solution, okay? So this is a solution is equal to am times t to the mth power. I mean, the solution has the form of the mth order polynomial, okay? Goes through the a0. Okay, so then here was question. So it come up with a question. So then what if the external force function is not the form of monomial, but sine function or any trigonometric functions or exponential functions? Then the solution, can you say the solution has the form of the trigonometric functions or sine the exponential functions that resemble to the external force? The answer was it's not always true. Okay, so the function, I mean, the source function itself suggests the form of the particular solution. I mean, a solution is not always true. Okay, and then then today I'm going to give that counter example. So then we'll see example. I'll get the example from my lecture note. Okay, so and then let me see. That was example. Actually, example 5 in my lecture note. Okay, so y second derivative minus 6y prime and then plus 9y is equal to e to 3t. Actually, I did solve this problem in previous video lecture, and then it turns out that I mean, here's the solution was like this. We just guessed that solution y of t is equal to a times e to the 3t. And then it turns out that y1t cannot satisfy this equation. So, because we got this y1 dou prime minus 6 y1 prime plus 9 y1, it turns out to be 0. Okay, so for any t, for any a, and for any t. Okay, so then, okay, so why? Here's a question then. Okay, so why is not y1 a solution? Okay. Okay, so because yeah, we need to figure out that. Okay, so here then the here answer because the actually y1 of t is the form of the general solution to the homogeneous equation. This is the form of a general solution to the homogeneous equation. Okay, equation. What's the homogeneous equation means? Homogeneous equation associated with the non-homogeneous differential equation. So which means y dot prime minus 6y prime plus 9y equals 0. Okay. So y1 of t is a solution, is the form of the general solution to that homogeneous equation, and that's why we got 0 right there. Yeah. So understand that? Yeah. I mean, so it means that what? It means that the Ox equation. I mean, yeah. Let's try to solve that homogeneous equation. Then we're gonna find the Ox equation. We solve the Ox equation, right? So r squared minus 6r plus 9 equals 0. So r minus 3 squared equals, I'm just, yeah, I'll just, the factor, the quadratic polynomial, we got this. So r equals 3. So this is double root, right? I told you. It's a double root. Okay. So then the general solution has the form, right? Y of t is equal to C1 e to the 3t, and then plus C2 times t times e to 3t. Right? So, and then we know that in a general solution, each term each term is a solution to the homogeneous equation. So this is solution. Oh, sorry. So this is solution of the homogeneous equation. This is also a solution of that homogeneous equation. So you see that C1 times e to 3t. This is the exactly same form as y1. Where's y1? You see y1 right there. You see? Okay. So that's why the y1t, I mean, even though y1t has the form similar to the external force in a non-homogeneous differential equation, that will not work as solution to non-homogeneous equation. Okay. So also we expect that this one also will not work as solution of that non-homogeneous differential equation, because we know that this is also solution of homogeneous equation. Okay. So now we guess what solution gonna be a times t squared e to 3t. Okay. All right. So now then, I told you, while we just, while we guess like this, a times t squared e to 3t, because the these two guys are solutions. We wanna guess a solution which is linearly independent to those two guys. It means that we wanna guess solution which is not the constant multiple of these two guys. Okay. So, or linear combination of these two guys. So we make sure that that solution, what we guess, is not a solution of the homogeneous differential equation. So one way is increase the degree of the t. Okay. So now, okay. So now, back to here, that we're gonna plug in this one to what that the non-homogeneous differential equation. Okay. So yp top prime minus 6 times yp prime plus 9yp, that's gonna be equal to yeah. So let me skip finding yp double prime and the yp prime. Okay, that should be in my lecture note. Okay, just look at that. Okay, because we don't have much of time, so I should finish this section today in this video. Okay, take finding the derivative yp and the second derivative yp, and then plug them into the non-homogeneous differential equation. Then we got the this one. Okay, that is equal to, by the way, e to the 3t. And then this one turns out to be what? 2 times a times e to the 3t. Okay, so now a must be what? 1/2. So we can say that yp of t is equal to 1/2 t squared, and the e to the 3t is a solution. Okay, solution to the differential equation. I'm sorry. Okay, the differential equation, DE. Okay, so now, okay, so then what circumstance we're gonna get this equation? I mean, okay, so uh, can you see that? What how, I mean, how we got this situation? I mean, how we got the why this one, a times e to 3t, uh, was not a solution of that non-homogeneous differential equation, because look at this, in a homogeneous equation, see that, and the root of the oxy equation, this one, is exactly same as what, the coefficient, the t, in an exponent of the exponential function in a external force. You see that, e to 3t. That's why this one, what, the could not be a solution, didn't work as a solution of non-homogeneous differential equation. Okay, so what if this one, r, is not 3 but 5 or 4, I mean other than 3, then I'm sure that worked, that did work as a solution of non-homogeneous differential equation. So okay, so now we're gonna build up the method of undetermined equation. So yep. So here, method of undetermined equation. Okay, equation. So first one, we sell this one already. Prime plus cy is equal to c times t to the m's power e to the rt. So I mean, we generalize this. Oh wait case. We're gonna generalize that case. You see that c times t to the m's power. So in more general form of this one is the c times t to the m's power times e to the rt. Then in that case, the form of solution gonna be t to the s power, and then am t to the m's power plus a m minus 1 t to the m minus 1 plus through the a0 and the e to the rt. All right, so what we got this is the what, nth order nth degree polynomial, right? So we got this because of this c times t to the m's power. Okay, and the e to the rt is in the external force. So yeah, so we put the e to the rt right there. And what about this t to the nth power? Well, we need this because if the r, you see that, if r is, I mean here r, if r is the root of the Ox equation, then that gonna be solution of the homogeneous equation. So we're gonna get big trouble. What we got in that example, right? Example here. You see that? So if r is now a root of the, let me say, just associate the Ox equation, then s is gonna be 0. If r is a simple root, okay, what does that mean? Simple root means that Ox equation, two distinct real root, right? Each root in Ox equation are called the what is called the the simple root, right? So if R is one of the simple root, then S must be 1, okay? And then M is, R is a double root, then S must be 2, okay? So we have 3 cases. If R is not a root of the associated Ox equation, then S equals 0, okay? And then if R is a simple root, okay, simple root, then S must be 1. And then if R is a double root, then S must be 2, okay? So now then, the second case. So AY dot prime plus BY prime plus CY is equal to C times T to the M. By the way, so some of you may wonder that what if the external force is just C times T to the M's power, and there is no, I mean, E to the RT is not involved. Then you just apply what? Where's one? You just apply this one, okay? If external force is just a monomial like the C times T to the M's power, then solution, a solution has the form like this, okay? Okay, that's this is, okay. And then the external force has a form like this, then a solution has a form like that, okay. And then we figured out why we need the T to the S power, right? And then second case, actually third case, right? C times T to the M's power, and then E to the alpha T, and then cosine beta T, okay, or C times T to the M's power, E to the alpha T, and then sine beta T, okay. So the external force is involved the trigonometric function, sine or cosine functions. Then what does the form of solution look like? So then YP of T is equal to T to the S power, and then mth order polynomial, right? Let me use sigma. Sigma m is equal to, oh, I'm sorry, let me use I. I is equal to 0 to m, and then AI, and then T to the I's power, okay? So, and then E to the alpha T, and then cosine beta T. And the plus T to the S power, and then sigma, K is 0 to the M, okay, and then BK, and then T to the K's power, and then E to the alpha T, and sine beta T. Okay. All right, so now we figure out S, right? Keep in mind this, the M right here, the degree of the polynomial in the external force, which is given. Keep in mind this, and the alpha was given, right? Okay. S, we need to determine that, okay? S must be determined. So how can you determine S? So we have solved the Ox equation, okay? So now then, if alpha plus I beta, I mean, so think about this. External force is involved the trigonometric function cosine or sine. It means that the solution must be involved sine or cosine, right? Okay. Then just think about the solution of homogeneous equation when Ox equation has the complex root. That is the only case we're gonna the solution is involved the sine or cosine function, right? Okay, so here external force is involved cosine or sine. It means that the associate Ox equation, it means that the Ox equation corresponding to this homogeneous equation, the Ox equation of the homogeneous equation corresponding to this non-homogeneous equation should have complex root. Okay, so now then, so under that, you know, under that, we can say that Ox equation gonna have two complex root, saying that alpha plus I beta or alpha plus I beta, right? I mean, and alpha plus I beta. So here, alpha plus I beta is not a root of the Ox equation. It's not a root of the associate Ox equation. Okay, so here, one thing you should keep in mind is here alpha and beta comes from alpha and beta in the external force. Okay, we're gonna compare the alpha plus I beta, which comes from the external force. Okay, all right. Do not confuse with alpha and I mean the real part and the immediate part of the complex root of the associate Ox equation. Okay, definitely we need to find out the complex root of the associate Ox equation and then compare this with that. Keep in mind this. Again, I've seen a lot of students made mistake or confused. They put they found out the complex root of the associate Ox equation and then plug the real part and then imaginary part of that solution complex root to here. No, the alpha and beta comes from this. Okay, external force. So now then Ox equation here, then S is equals 0. Okay, and the alpha plus I beta is a root of associate Ox equation. S must be 1. Okay, in a complex root, I mean, if discriminant less than 0 in an associate Ox equation, then we only have one case, the simple root, right? Okay, there's no double root when D is less than 0. I mean, discriminant less than 0. Okay, so excuse me, if alpha minus I beta is a root, okay, of the Ox equation, Ox equation, S equals 1. Okay, so I know it's maybe it's it may take time to understand and memorize whole things, but the just please understand the why do we need a T to the S term? Okay, keep in mind this. All right, it's confused. So definitely you need to practice by solving a lot of examples for this one. Okay, so now let's see examples in textbook. Okay, so give me a second. All right, so let me share the textbook. Give me a second. All right, so excuse me. So what we're doing is chapter 4, right? And then 4.4. So we don't have much time, so I cannot go over every single examples in textbook. So please study all of the examples in the textbook. This is really good, and then you should do that in order to solve in order to work the online homework. Okay. So let's see. All right, so now look at just take a look at this example 7. Okay, so find the form of a particular solution. Here, particular solution doesn't mean, I told you, doesn't mean a particular solution of initial variable problem. Okay, it's just that means it's just a solution. Okay, so let's see here. Oh, okay. So now you see that here the external force 5 times t times e to t and times cosine t. So what? Then the general solution, a solution has the form dt. Can I write it down? Give me a second. So let me copy this problem in the my scratch paper. Okay. So give me a second. So yeah. So now example 7, and then y second derivative minus 2y prime, and then plus 2y is equal to 5t e to the t, and then cosine t. Right here. You see that here? So what we're going to do, step 1. All right, so we need to copy. We need to figure out the type of external force term. Okay, so the polynomial times exponential function times trigonometric function. Then we saw that, right? This is the actually the second case right there, right? So the solution, a particular solution must have form like that, right? So then y, let's say yp of t is equal to t to the s power, and then what was this? am t to the m's power plus am minus 1 t to the m minus 1 plus through the a0, right? And then e to the alpha t, and then cosine beta t, right? And then plus t to the s power, and then bm. Oh, can you see that? And then t to the m's power plus bm minus 1, t to the m minus 1 plus through the what? b0, e to the alpha t, and then cosine, sine beta t. Okay. Okay. So let's figure out all the parameters s, m, alpha, beta. Okay. So what? First one, m is what? 1, right? What does m means? M is what? Degree of the polynomial in the external force. 1, right? And then alpha is what? The coefficient of t in the exponential function, right? So this is 1. And the beta is what? The coefficient t in a cosine is 1. Okay. So then the only thing we need to figure out is what? S. To figure out S, we have to find out root of the associated ox equation, right? Okay, so this is kind of step 2. So we find root, root of the associated ox equation. Okay, so now, excuse me, this ox equation, yeah, so then here ox equation gonna be r squared minus 2r plus 2 equals 0, right? Then r gonna be, I think we gotta, to solve that quadratic equation, we have to, let me see, we have to use the quadratic formula, right? So r gonna be 2 plus minus square root b squared minus 4ac divided by 2, which is 1 plus minus, right? And then I. 1 plus minus I, right? I right there. Okay. So here we're gonna compare what? Then alpha plus I beta. We're gonna compare this one with 1 plus I. Okay. All right. So I mean, we're gonna compare the alpha with the real part of the root of Ox equation, and then we're gonna compare the beta with the imaginary part, in root of the Ox equation. As you can see that alpha is what? 1, right? What is the beta? Beta is 1, right? So alpha should be equal, alpha is equal to 1. Alpha is just matched with the real part in here, and the beta is matched with the imaginary part and root of Ox equation. Then what is S? You can say since alpha plus I beta is equal to 1 plus I, right? I, S must be what? 1. Okay? 1. What does that mean? Why S must be 1? I told you several times. Alpha plus I beta is what? Is equal to 1 plus I. It means that alpha plus I beta is a root of that Ox equation. It means that e to the alpha times cosine beta t plus e to the alpha t times sine beta t. I mean, each terms must be solution of the to the homogeneous equation. Okay, that's why we put this. S must be 1. Okay, so it means that when you without this t to the s term, without the t to the s power, this will make the left-hand side to be 0. It shouldn't happen, right? It shouldn't happen. So as we put this one, t to the s power, to make this one not a solution of a homogeneous equation. So s must be 1. So now then y b of t, his form is step 3, is equal to t times a, right? A1 t plus a0, and the e to d t, and then cosine t plus t times b1 t plus b0, and the e to the t sine t. Okay,